When two objects stick and move together, they can be treated as a single object with mass equal to their individual masses added together. Remember that momentum is the product of the mass and velocity of an object. It's a really important quantity in physics, as the total momentum in a closed system won't change. This means that the total momentum before a collision is equal to the total momentum after a collision. If we're given information about the velocities and masses of objects before and after a collision, then we can use this to calculate a piece of missing information, such as the velocity of an object after a collision. So how do we tackle calculations when two objects stick together? Well, let's start with a simple general example as shown in this diagram. We have two balls which are initially separated, then after a collision they stick together and move as one. We'll use this dotted line to separate the before and after stages. Before the collision, let's say the two balls had masses of m1 and m2, and they had velocities of u1 and u2. The letter U is a common algebraic symbol for initial velocity. We've also shown the direction of these velocities. It's important to treat velocity and momentum as vectors, so we need to consider if these values are positive or negative. We then find the total momentum of the system by adding the individual momenta together, giving us m1u1 plus m2u2. Now, after the collision, we can treat the two balls stuck together as a single ball. The mass of this ball will be the individual masses combined, so we can write this as m1 plus m2. We'll then say that they both move with some velocity v. Again, we should specify this direction so we know whether to treat it as a positive or negative velocity. The momentum of the stuck balls is then just the product of these, which is m1 plus m2 all multiplied by v. Now we can relate these totals using the principle of conservation of momentum, which tells us that they must be equal to each other. You don't need to know this algebraic formula, but you should be able to use the relation between these two totals and the idea of adding masses when objects stick to solve problems. For example, you could be asked to find out what this velocity after the collision would be. Let's try an example of this now. Two trolleys of masses 4 kilograms and 3 kilograms are projected towards each other, with speeds of 5 meters per second and 2 meters per second respectively. After colliding, the trolleys stick together and move in the original direction of the 4 kilogram trolley. Calculate the speed of the joined trolley after the collision. Now that's a lot of information, so let's start by setting this out as clearly as possible, both for ourselves and for the examiner. This isn't essential, but it will help ensure we don't get confused later on. So for step 1, sketch and label a diagram of the collision described. Here we've done a rough sketch of the two trolleys before the collision and how they'll join together after. Let's put a dotted line to separate these. In an exam, it will always be stated explicitly if two objects stick together after a collision. You won't be expected to predict whether objects stick or not. Before the collision, we're told that the trolleys have individual masses of 4 kilograms and 3 kilograms. We're also told that the first trolley has a speed of 5 meters per second. Let's say it's travelling to the right, and we'll also call this the positive direction for our working. This is really important, as we're told that the two trolleys were projected towards each other, so the second trolley must be travelling in the opposite direction, to the left. It has a speed of 2 meters per second, but since this is opposite to our positive direction, we'll be treating this as a negative number. Now for after the collision, we know that the two trolleys join together as a single object with a new mass. For now, let's write back in their individual masses so we can work out the combined mass later. We're told that the combined object moves in the same direction as the 4 kilogram trolley, so we'll put an arrow showing it also travels to the right. Then we're asked to find its speed, which we'll label as v. Because of the direction given, we should expect a positive value here. Then in step 2, calculate the total momentum before the collision. To do this, we'll be using the equation that momentum equals mass multiplied by velocity. then the total momentum will be the sum of the two individual momenta of the trolleys. So the total momentum is the momentum of the first trolley, which is 4 kilograms times by 5 meters per second, plus the momentum of the second trolley, which is 3 kilograms times by minus 2 meters per second. Remember that the second trolley was travelling in the opposite direction to the first, so we need to use a negative number for its velocity. Overall, we find that the total momentum is 14 kilogram meters per second. In step 3, determine the total momentum after the collision. We'll do this using the principle of conservation of momentum, which tells us that the total momentum after a collision must be the same as the total momentum before it. In this case, we know that the total momentum after the collision is 14 kilogram meters per second. Then in step 4, calculate the mass of the joined trolley after the collision. Now this is the key step in this kind of momentum question. We need to use the fact that when two objects stick together during a collision, we treat them as a single object with a mass equal to the total mass of the individual objects. In this case, the joined mass of the two trolleys is equal to 4 kilograms plus 3 kilograms, which is 7 kilograms. Now we can use this mass and the momentum to find the speed of the combined trolley. We'll do this using the equation for momentum. So in step 5, rearrange the momentum equation to make velocity the subject. Remember, this is momentum equals mass times by velocity. Speed is the scalar form of velocity, so if we calculate the velocity and it's positive, we can just give that value for our speed. To make velocity the subject, we should divide both sides of the equation by mass in order to get velocity on one side on its own. This gives us that momentum divided by mass is equal to velocity. Now for the last step. In step 6, calculate the speed of the joined trolley after the collision. If we flip our rearranged equation, we get that velocity equals momentum divided by mass. If we then replace velocity with speed and substitute the momentum and the mass that we've calculated, we get that speed equals 14 divided by 7, which gives us a speed of 2 meters per second. Again, since we're told the direction of the joined trolley in the question, we don't need to worry about checking if this value is positive or negative and determining the direction ourselves.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!